If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are starting concepts of hyperbola. So today we will see the standard equation of hyperbola and we will make some observation from these standard equations like we have done for ellipse. Okay, then let's see this. So in hyperbola, basic and intermediate both I am doing at the same time. I have not break it at basic and intermediate level because, and I am giving it in intermediate playlist also, because in basic level, that is for diploma, it is not there in syllabus in diploma. So that's why I am putting hyperbola directly on intermediate. So okay, so if we start with the standard equation, so approaches will be same as your ellipse and almost everything will be same, last a slight difference. And in many places I may have by mistake written ellipse also, you kindly correct it. So it is of similar way. So you remember in ellipse what we have done, we have first taken a point, BC is a directrix we have taken, and similarly A is a point, extreme points we have taken, which is at a distance of A units from O. So this is A comma 0, this side you don't come now, so just you think for this side only, just this line BC, initially you think this is a BC line and this is a point A, and similarly there is a point focus F. So that is because the distance from focus will be more here than the distance from the directrix, because this is the fixed point, that is ellipse, here E is more. So this length will be more than this length. So if you plot it, you will get something like this. And similarly you can find something of this fashion also here also, where it is, you can see this length is more than this length. So here also at some points, at all points, this length is more than this length. So with this directrix and focus you find another curve also in this direction, like ellipse, both sides you have found with same focus and directrix. So first let us find these coordinates like the way you have done for ellipse. Here it is E is greater than 1, that you have to think of PM by PF by PM, which is nothing but at, if you take this point AF by AN, and if you come to this side focus and directrix you forget, just think about this curve. This curve is coming taking this focus and this directrix only. So similarly it will be A dash F divided by A dash N, the distance from the directrix, distance from the focus. To find the coordinate, similar way like approach, if you do it, I am not showing it like exactly same way. So if you do it, you will find ON is the distance of A by E, OF is AE. Formulas are also okay, same. But why directrix is coming before focus? Because E is now greater than 1. So it will be smaller, it will be higher. In case of the ellipse, it was coming first, it was coming later, because E was smaller. So this value was smaller, this value was higher. What is the equation of directrix? So it is the equation of directrix, it is at focus, one focus and one directrix, another one will come later on. So for similarly for hyperbola, you know this PF should be equal to E times PM, this one. So distance from the point should be E into distance from the line, like the similar way what you have done for ellipse. You will find this equation in ellipse also. So you have find this equation in hyperbola also same. But in ellipse E was less than 1, so E square was less than 1, so we kept it like this. But in hyperbola, because E is greater than 1, so we know this value will be negative, so that's why we put it minus there. So now it will be okay, because E square is greater than 1, so it will be always positive. So it will look like x square minus s square minus y square by something will look like. So that is the difference, that's it. So here it will be just 1 minus e square, it is e square minus 1, because E is now greater than 1, so actual figure will look like this. So the actual equation will look like this, x square by y square minus, in ellipse it was plus. That's the difference, nothing is same, everything is same. Here your v square is equal to a square into e square minus 1, E is equal to, now here it changed that, it changed 1 plus v square by a square. Here in the earlier one, ellipse, it was a minus v square by square, that's it. Now some observations that we can make out from this, like every figure we have done, this curve is symmetrical about x and y axis, because if you put x minus x, it is same, y is instead of y, if you put minus y, it is also same. So it is symmetric about both axes. You can see it is symmetric about x axis, it is symmetric about y axis also. Now if you see, if your x square is less than a, because if you calculate y is equal to y square by b square is x square by a square minus a. So if your x square is less than a, this will be negative. Once this negative, y square cannot be negative. That means you will not find any points which satisfies this one. That means no part of the hyperbola lies in the interval between minus a to a. So if it lies between minus a to a, because this is your minus a, if you lies it between minus a to a x, so your x square will be less than a square. Because if you take, you know, x square is less than a square means x minus a, x plus a is less than 0. then you can solve it by using placing poles. I have shown you. So this side is plus, minus, plus, so this is negative zone. So A cannot be this minus 1 to 1, because if it is so, then y you will not get 1. So there will be no real y. So you can see no graphs it is in between x equal to minus a, x equal to a. So in this zone there is no graph. Hyperbola is completely outside there. But similar thing is not happening for y square is less than b square. Because why? Because now x square plus y square is equal to 1 plus y square by. So plus means you can take any value. X square will not be negative. So for y can be anywhere. So you can see y can reach up to infinity also. It is keep on growing. It is keep on growing. So there is no limitations in y-axis. Y can go anywhere, but x there is a limitation. X cannot be between minus a to a. So this zone is not in your hyperbola curve. So if x tends to infinity, then y also tending to infinity. So it is an infinite curve. If you like the video, then press the like button and please give your valuable comments in the comment section.